Introducing the Expedition 4041 flight crew. NASA astronaut Reid Wiseman is a naval aviator and test pilot. He has a master's degree in systems engineering from Johns Hopkins University. In 2009, while serving as a lieutenant commander on the aircraft carrier Eisenhower, Reid was selected by NASA to become an astronaut candidate. In his spare time, Reid enjoys golf, woodworking, and running. Max Saraya returns to the International Space Station. A graduate from the Kasha Air Force Pilot School in 1994, Max received a law degree from the Russian Academy of Civil Service in 2007. While serving as a flight engineer during Expedition 22, he performed a 5-hour, 44-minute spacewalk. Max is a qualified scuba diver. From Germany, first-time space flyer Alexander Gerst received a master's degree in Earth Sciences from the Victoria University in Wellington, New Zealand. In 2010, Alex graduated with a doctorate in natural sciences at the Institute of Geophysics from the University of Hamburg. He was selected as an ESA astronaut in May 2009. Alex is a skydiver and a snowboarder. Reid, Max, and Alexander are due to launch to the International Space Station aboard Soyuz 39 in May.
Good afternoon. Thanks so much for joining us for a special briefing with one of our next crews headed to the International Space Station. Gentlemen, thanks so much for joining us.
Absolutely.
That was quite a video, gave us quite an overview, but we still want to talk to you a little bit and learn a bit about each of you, and Reid, we'll start with you. You and Alex are both relatively new to NASA. You joined the Corps in 2009. Sure. You've got a great background, multiple engineering degrees, commander in the Navy, and served as a test pilot in several deployments. Can you tell us a little bit about the training that you've done here, both as an ASCAN and then especially once you got that mission assignment?
Absolutely. So the ASCAN years, the astronaut candidate years, it's basically a 2-year flow, and we're really focused in just getting our feet wet into life at NASA, learning the core systems on the space station, certainly learning Russian language so that we can communicate better with our Russian colleagues, learning the very basics of robotics operating the Canadarm2. And then we kind of conclude by focusing on spacewalking skills, very basic in the pool. And that small amount of information really does take that full 2 years. And we also did a little bit of geology work, which was some of my more favorite activities. And then as I transitioned into the assigned training flow, it really is this same core subjects, but we just take it to the next level. So you're honing the skills on space station. You're trying to master working in the spacesuit. Of course, we haven't done a spacewalk, but you're trying to learn as much as you possibly can so that if that event occurs, you're ready to go. And then you're finishing up your robotic arm skills, getting the Russian really squared away. And there's no better way to learn Russian than to live in Russia and work with Max and learn that way. So that's really about the last 4.5 years of my life, wrapped up in a few words.
Probably seems like a blur at this point, right?
It seems like a blur. It's amazing how quickly it's gone.
And I'm just kind of curious, relative to the other training you've done, like the test pilot, aviation, and engineering, how would you compare this? Has it been more intense or just completely different?
It is completely different, really. There are days that are much more intense, but overall, it's fairly similar intensity. The big difference here is when we launch into space, we basically have to have this incredibly broad skill set. And my previous professions were more focused on individual missions. Let's train up for this, we go fly this. Train for the next, go fly that. And for us, we kind of need to have our hands on everything, because once we launch, it's 6 months and it's all on us.
So speaking of, this would be the first space flight for the two of you. So rookies training together, and I think that might be kind of special to have two rookies preparing together. How did that work out? Did you guys study a lot together or rely on past veterans to help you through? How did that go?
Certainly for our time in Russia, where we generally don't have our families there, there's been many nights where Alex and I have spent, especially studying the Soyuz, our launch and entry vehicle. For the space station, we're together basically all the time, every day. We're together in our classes. I don't know if you want to expand or not.
Yeah, I guess it really depends on which training you do, where it's really beneficial to work together a lot. Like for the preparation for the NBL runs, the training runs in the space suit, in the dive tank that we have here. It's very important that you prepare together, because you need the same mental picture of the tasks that lie ahead, and so you get the timeline in your brain, basically, because it's a lot to remember there. You have a 6-hour timeline, basically, sometimes down to single hand motions that you really have to memorize. And also in training you actually do this training by developing those timelines. Like you're not just given them, but you actually need to develop them in order to really think about the intricacies of doing a spacewalk. And that is really the time where you spend hours and hours together really preparing for the day of the run.
Yeah, so you probably all three know each other very well at this point.
Maybe a little too well.
Speaking of Max, how is it for you having, this won't be your first mission, you're a veteran, and having two rookies on the flight, how's that been?
You want me to answer in English or Russian?
English would be great, or Russian, and then you can provide us.
Ну, давайте тогда на русском, поскольку я из России.
Отлично.
Да, но мне очень приятно и очень комфортно работать с этими ребятами.
Given that I'm from Russia, let me answer in Russian. It's very nice for me to work with these guys.
Потому что действительно ребята профессионально, я считаю, готовы. Потому что они знают очень много, они очень старательные. Мы прошли очень большой курс тренировок с ними. И как тренировки только касаемые науки и каких-то научных тем. И что касаемо тренировок по выживанию, то есть я абсолютно в ребятах уверен. Я думаю, что у нас будет хороший экипаж.
They know a lot. They're really professionally well trained. We've gone through a lot together, both as far as research and science training and as far as survival training is concerned. I am absolutely certain of them having my back.
Right. It's a great way to start the mission. Well, we have a packed room here at the Johnson Space Center, so I'd like to jump in with some questions. So we'll start with media that are here at Johnson. If you can give us a minute just to make sure we have our cameras in place, and then state your name and affiliation. And I believe we'll start over here first.
Gerhard Daum with the German Space Agency and Space Expo Association. Question for Alex. You almost completed your training for the mission. What major milestones are coming up the next 2 months until launch? Could you please answer in German and in English?
All right, which one do you want to hear first? Ja, okay. Wir sind jetzt um die 70 Tage vorm Start und im Prinzip ist es ja so, dass man als Mannschaft, die zur ISS fliegt, eigentlich schon ein halbes Jahr vor seinem Flug vollkommen ausgebildet sein muss, weil man da die Ersatzmannschaft ist für die Mannschaft, die ein halbes Jahr vor einem fliegt. Das heißt, letzten November waren wir in Baikonur, da mussten wir vorher schon alle Prüfungen bestehen, um wirklich notfalls als Ersatzmannschaft mit der Soyuz zur Raumstation fliegen zu können. Und was danach dann kommt, ist eigentlich mehr Training für wissenschaftliche Experimente. Das heißt, da werden Basisdaten, Vergleichsdaten gesammelt, die dann hinterher nach dem Flug mit den Daten verglichen werden können, die wir im Orbit sammeln und nach dem Flug. Dann werden nochmal wissenschaftliche Experimente trainiert, die wir sonst nicht trainiert haben als Backup-Mannschaft, weil wir die gar nicht gesehen hätten auf der Raumstation, wenn wir als Ersatzmannschaft geflogen wären. Das heißt, das Training zwischen Ersatzstart, Backup-Start und dem eigentlichen Start ist mehr mit Details gefüllt, die man dann wirklich auf der Raumstation dann zu erledigen hat. Also man trainiert da wirklich ganz konkret Arbeiten, die man dann da oben ausführen wird im Detail. Der nächste große Schritt, den wir haben vor unserem Flug jetzt, ist nochmal, dass wir nochmal die Prüfungen durchmachen müssen. Das heißt, die wir schon mal gemacht haben vor dem Backup-Start, die machen wir jetzt nochmal in Russland. Das ist nochmal ein großer Schritt. Und dann geht es dann gleich schon los nach Baikonur und wir präparieren uns für den Start. Das heißt, es sind nicht mehr viele große Milestones übrig, die wir bis dahin haben.
Do you mind sharing that for us in English for the rest of our group and our viewing audience?
So as a crew that's flying to the International Space Station, you principally have to be prepared, completely prepared with all the exams done and everything before your flight, about half a year before you fly. And that's the time when you're a backup crew for the crew that flies half a year before you fly into space. And that means all the major milestones you have to go through until that point. So between the backup start and the prime start, which for us is the 28th of May, we mainly train payloads, experiments that we would not have seen on space station if we had flown as a backup crew. Then we collect baseline data for scientific experiments, that the scientists need to compare for the data that we collect in space or after we return. And that's mainly what fills our days right now. Of course, there's also last-minute training for tasks that came up that we will do on orbit. We train these in detail, like exchanging a certain part of space station that I haven't trained on so far, but that just came up because it might be a hardware that needs to be changed out. So that's kind of last-minute training that we do now. And the only remaining milestone is the repetition of those exams that we did also for our backup start, which is in Russia. It's the Soyuz exams in the Russian part of the stations. So it's a 2-day big exam that we have to pass in order to be qualified to fly to space in the Soyuz capsule. And that's about the only major milestone that remains, and it's already going to Baikonur and preparing for the launch.
Okay, thanks, Alex. I think we had a question here, Gina.
Gina Sinceri, ABC News for Alexander and Reid. You're both active on social media, and I'm just curious how you will use that on orbit to share your experiences with your followers.
So we're both rookies, and I think that adds just a little touch of, maybe not passion, but just a little unique perspective. We have not flown to the space station. We haven't even flown into space. And so every event for us is kind of new. And I think if I can share that on Twitter, that almost childish enthusiasm for the mission, that's really something that I look forward to. All the unique events that I have. Well, I just opened my food and I have Cheerios everywhere. Or, you know, this experiment went really well, but this one was just terrible, and here's why. If I can get that across, that would be great. And then another thing that I would love to do on Twitter is try to get the folks that are following us involved just a little bit. And so I'll try to initiate it from space this summer, but maybe just a come out and wave campaign where if maybe a parent can take a child out and just watch the ISS fly overhead and wave and then tweet about it. And I'll try to kind of build a map of where all those tweets came from and see who around the world is coming out and watching, and try to get more people involved that way and spark some imagination.
Yeah, I can just totally agree with Reid here. I think he hit the most important point, is that both of us, we haven't flown, so we have been to space as many times as you guys have been. And to me, it's an important thing to share how it is as a person who's never been to space to do all this for the very first time, to see all this for the very first time. And that is a perspective that many people can relate to, because for them it would also be the very first time. And also, for me, it's a great way to conserve all this, because I don't have a time really to write a diary. So kind of being on Twitter or writing a blog kind of forces me to conserve some of those memories that otherwise might just fade away after a while. So yeah, to me, it really helps, and it's of course a lot of fun to see the reactions of people. Because some questions come up that I could have never thought of, and it was really funny sometimes to see that.
So you guys both kind of touched on all the new experiences and new training. I'm just kind of curious, is there any particular training that stands out that was really surprising or really more exciting or dramatic or different than you expected? Is there any singular?
We don't have enough time.
So it's nothing one.
Well, as always, any work that we do in the neutral buoyancy lab in the spacesuit is, from day one, that shocks me as to how physically and mentally demanding that is. And I used to think my old job was very demanding in just pace, and your brain's always working. But you put on a spacesuit and put yourself underwater for 6 hours, and you're just exhausted in the end, in all ways. So that always stands out in my mind, is people just don't really grasp. It's impossible to grasp how difficult that is until you go and do it.
Right. So, Alex?
And again, agree. I remember on our last run that we did in the spacesuit, it was last Friday, and in the morning when we got out of the car at 6 o'clock, I tweeted a picture of the dark parking lot. Our cars were the only ones there. We were preparing to get in there, and that's always a kind of a hard time in training, because you have this big task ahead. Like in total, you're like 8 hours total concentration. You cannot do any break, and I mean, it's physically demanding. You're in the suit, you work against the pressure of that suit all the time that wants to return you into a neutral position. So every time you squeeze, you grab a handhold, it's like squeezing a tennis ball, and after like 7 hours, that really adds up to, I mean, what you've done. And it's amazing how that transforms. Like that anticipation of the hard work, but once you're in a spacesuit, it just fits like a glove, and it's like you feel like you can do this, and you imagine, how would I do this if I was in space? And suddenly it's a lot of fun to train that, and it's a big reward when you come out at the end of the day and you know what you've done, and that's the training that's amazing.
Can I just clarify one spacesuit thing though?
Absolutely.
I hear it all the time. You can't itch your nose.
Yeah.
But you can itch your nose because we have a little Valsalva, so you can scratch your nose. The thing you can't do is itch your eye. So if you, you do that so many times during the day, but in the space you can't do it. And I know on Friday I was just like, it's not my nose.
Okay.
But it is a universal.
Sorry, we digress.
It's a universal physical law.
Heard it here.
It's a universal physical law that whenever you're in a spacesuit and you put your helmet on, that moment your nose starts itching.
Gotcha. It figures. Murphy. We all know him. Okay, and Robert, we'll take it over here.
Hi, Robert Perlman with collectspace.com. For Reid, you recently tweeted, at least in the last couple of weeks, that you were adding a run around the world on the treadmill to your on-orbit bucket list.
Certainly.
So I want to know what else is on that on-orbit bucket list.
I have to still go back and parse out the amazing responses from that single tweet. I basically asked Twitter followers, what would you put on your on-orbit bucket list after Mike Hopkins did his run around the world a few weeks ago. So certainly run around the world is on there. I have to look out the window. I really want to take photographs of the places that I've lived. That's kind of just a personal ambition. And then really, I haven't finalized this. I do need to do some work on it. But just sharing this experience is number one on the bucket list. If I can get that done, success.
Okay, I believe we have another question.
Jim Oberg with NBC. Hello. And it touches your question about two new guys and the veteran going up. In the spare time, after midnight, are there any occasions when, and Max you can answer too, when he will tell you something the teachers won't tell you, but let me tell you how it really is, and here's what you have to, they won't teach you this, but I will. Any secrets of your experience, your blogging, anything else that you've shared with them that they can pass on? Well, did you see if
I'll gladly start with just he told us this one last week. When we first get on board, we were over in the space station mock-up, and we were going through some class with a bag, and you open it up, and inside are all these little parts. And Max just chuckled, and he said, when you do this in space, take this bag into your crew quarters if you do it in the first few weeks where it's real small, and open it up in there so that when all this stuff flies out and it's floating around everywhere, you're in a small little room and you can grab the parts. Because if you open that up in the US lab, it's going to take you 6 hours to go collect all that and put it back in the bag. So the things that we gain from Max and from the other veterans are the things that are impossible to teach from a 1G perspective. So how do you just live in microgravity? And he's done a great job teaching us that.
Like how to fly at the beginning. Maybe you can tell that again because.
No, it's okay.
Basically, he said like. He basically said when you fly to space the first time, people tend to float with their kind of legs a bit spread, and that just for stabilization, and that sometimes leads to kind of ripping down things in the walls that you don't want to rip down. So he kind of recommended take something like a book or and put it between your knees to force your legs to be closed, because that way you have a slimmer profile floating along station. That was, I guess, one of the ones that I tried to keep in mind when coming up there first time.
Sounds useful. Thank you.
Okay, thank you. And I believe we have a question in the back. Go ahead.
Hi, I'm Stefan Georgievich, and I'm an intern and a medical student here at NASA. Speaking of floating, what happens when you get stuck in a room? How do you get out of that stuck orientation?
Oh, you mean if you float in the middle of the room?
Yeah, you just stop. What happens next?
Well, I have to ask Max here, I guess.
Ну, знаете, потому что ты не можешь двигаться, да, ты не можешь оттолкнуться, и поэтому ты зависнешь в невесомости в одном месте, насколько я понял, правильно?
As far as I understand, this is because you can't move, because you can't push off a surface, and that's why you're stuck in place.
Ну, давайте так, я могу сказать, что у меня был очень хороший шанс и эксперимент, когда пришел Note 3 на американский сегмент, я был как раз в это время в космосе. И когда еще стойки все не были установлены, было очень много места. И я специально попросил Олега Котова, чтобы он меня поставил посередине модуля, чтобы у меня не было возможности за что-то схватиться.
I've had a very good chance and a very good experiment when Node 3 arrived on station and all of the racks were not installed yet and there was lots of room there. I asked Oleg Kotov to place me in the middle of the module in a position where I couldn't grab onto anything.
И вы знаете, действительно, ты можешь двигаться как угодно, извиваться как змея, но ты не сдвинешься с места, потому что ты не можешь оттолкнуться от воздуха.
And it is true that you can twist as much as a contortionist, but you are not going to be able to move because you've got nothing to bear against.
Но на самом деле на станции есть вентиляция, и вентиляция очень хорошая. Поэтому всегда присутствует какой-то небольшой, ну, присутствует сквозняк, присутствует ветерок.
But there is ventilation on station, and it's a very good system, so there's always a draft. There's always some wind there.
И то же самое происходит с вещами, когда, и это будет обязательно на станции, что очень часто люди теряют вещи.
The same thing happens with things, and that's going to continue to happen on station. People lose their stuff frequently.
Единственное место, где ты можешь найти потерянную вещь, это вентиляционная решетка, потому что рано или поздно все равно она туда прилетит, то есть ветер и сквозняк ее туда принесут.
The only place where you can find something that you've lost is a ventilation opening, because that's where things are going to wind up sooner or later. The drafts, the wind is going to take them there.
И вы знаете, я хотел сказать, но это пришло ко мне в прошлом полете, действительно, в ходе вот этого эксперимента. Может быть, это как бы не на пленку, может быть, это... Но я подумал о том, что если когда-то в космосе будет жизнь постоянная людей, и если когда-то будут города, то это самый лучший способ держать человека в тюрьме, когда он просто находится нигде и не может никуда подвинуться. На самом деле это очень страшно.
And I thought that if ever we have permanent human habitation in space, this would be the best way to keep a person confined, like in prison, in the middle of a room where he or she cannot move anywhere, being in limbo, as it were.
Для этого только надо человека, большую комнату, несколько вентиляторов, чтобы они его держали в середине комнаты, и все. На самом деле, поверьте, это страшно.
The only thing that's required is a large room, a person, and several fans blowing in different directions to keep the person in the middle of the room. That's scary, trust me.
Okay, we're learning lots of great stuff during this break. This is wonderful. I believe one of our questions alluded to social media, and I want to remind everybody that we are taking questions real time. So we'll turn it over to Amiko, who I believe has got some questions via Twitter.
Yeah, so welcome, guys. You guys are both on Twitter. We talked some about that. So a lot of people on Twitter are very excited to be able to ask you a couple questions. One of them, can you tell us of your primary mission objectives? We saw some of that in the video in advance, but maybe something that you know you're going to be focused on. And more importantly, as a team, how do you intend to achieve these goals?
Well, sure. The ISS, as you know, is this amazing microgravity laboratory that we have in space, and we have transitioned almost completely into the utilization phase. So for us, it's a continuation of the main objectives, which is how do humans live in microgravity? How can we survive up there for 6 months or longer so that we can eventually make these longer missions out to an asteroid or to Mars? So our primary objective is going to really be in the human sciences area, to really continue to see what's going on with our skin, our eyes, our heart, our bones, our muscles. So lots of good experiments in that. And then also, we have this extremely complex machine, and this machine has to keep us alive. So continue to stress these environmental control and life support systems, our water supply, oxygen, CO2 scrubbing. We need to continue to hone these machines so that we can eventually push out further into the solar system. And then also just with the station extending out to 2024 now, you'll start to see in Expedition 40 and 41 where we begin to lay a little of the groundwork for this extension. We're gonna move a module in 2015, so we're gonna hopefully go outside and move some of the hardware around so that module can be moved. And this is getting us ready for commercial crewed vehicles, bringing up astronauts using commercial vehicles in hopefully 2017 or 2018. So those are our primary mission objectives. And how are we going to accomplish them? We have Steve Swanson on Expedition 40, and then Butch Wilmore will be coming up in 41, both seasoned astronauts, and our teamwork so far with all of them has been fantastic. Great team cohesion, and working with the ground, we'll get all the objectives done, no doubt about it.
And obviously working together as a team is how it's going to happen, otherwise you're going to find yourself in the middle of a room.
With ventilation.
One more question for you before we go to other questions out here. How do you get accustomed to microgravity, and which part of the space station do you expect to like most, excluding the cupola? Excluding the
Well, which part will you like the most? For most people that come back, Node 1 is what they like the most. And the reason is there's a dinner table there, and that's really the eating area for us, especially on the American segment. And that's kind of this little community area where the workday is done. Let's all come together around this dinner table and let's just eat. We'll share stories. We'll invite our Russian colleagues down to join us. And that's where kind of the human side memories seem to be formed on the space station. So that's really, I think, what we'll end up enjoying the most. How do we get accustomed to microgravity? Oh, I think everybody has their own answer. Fluid shift, you're going to be stuffed up. Some things will be really fun. Some things will be really frustrating. We've got Max and Steve Swanson up there, and really just, we'll put the burden on those guys to teach us what we need to do. So that's the plan.
Do either of you want to add to the favorite location, or?
Yeah, I think again, I have to agree with Reid here because it's really, I think, a social place in Node 1. And if you think about it, the space station has about the same interior volume as a Boeing 747. So 6 people can really distribute themselves quite a bit, I guess. And the way the work is set up is that Reid's a specialist for the US laboratory, so he's doing work in science in the US science laboratory. I'm going to do the same in the European Columbus laboratory and in the Japanese Kibo. Max is working in the Russian segment. So we're going to be spread out quite a bit on space station. So I guess at the end of the day, it's kind of nice to meet up with your crewmates and just chat about how the day went, and I'm looking forward to that. Yeah. On the professional side, so that was kind of the personal place, I guess, where I'd like to be most. And then on the professional side, I'm going to enjoy working in the laboratory modules, of course. And I think that's true for all of us. We have a big suite of experiments. I think we have about 162 experiments in the time that we're up there, and that's really a lot. Of course, the amount of training that you get and work that you put in a single experiment really varies. There's some experiments that we only going to install, just put on power, and as long as it works, it's going to be run by the ground. Then there's other experiments where we can really get hands-on, and those are the ones that I'm looking forward to working the most in.
I was just going to ask if there's one experiment in particular for each of you that is something that you've really become interested in. Is there anything like that for any of you?
There's one that really piqued my interest, but I had to think about it for a little while. And it's just a little footnote on our list, and that is in the Expedition 41 timeframe, we'll hopefully get 3D printer. Mm-hmm. And at first I just thought, okay, 3D printer, we'll throw it in a science rack and we'll just see if it can print. But then I really started to think about the long-term implications of 3D printing. Mm-hmm. Imagine if Apollo 13 had a 3D printer. Imagine if you're going to Mars and instead of packing along 20,000 spare parts, you pack along a few kilograms of ink. And now you don't even need to know what part's going to break. You can just print out that part. Or let's say your screwdriver strips out halfway to Mars and you need a screwdriver. print out a screwdriver. So really, I think for the future, that's pretty fascinating. I really like that, and it'll be fun to play with that on orbit.
I was just going to say, we can expect a lot of gadgets being cranked out now while you're up there.
It doesn't print food yet, though.
Soon, I heard, soon.
Not yet. Anything for either of you? Particular experiment that you're interested in or looking forward to working on?
You know, I get this question a lot, and I always have a hard time answering because there's so many really good ones. So if I pick out one, that really doesn't mean the other ones are any worse. For me, there's one that I'm going to like because I'm going to install it from the beginning on. I'm going to receive it from the European transfer vehicle, the ATV-5, that's going to arrive on space station in July, August timeframe. And I'm going to install it in Columbus, and I'm going to check it out, do the tests, and maybe see the first runs. And that's the electromagnetic levitator. It's an alloy furnace that enables us to investigate alloys, physical properties of new materials that we cannot test on Earth, because the way that you need to investigate or get out those secrets of that little drop of molten metal is that it cannot touch any furnace or any box that it lies in, any surrounding place. And if you think about it, that's completely impossible on Earth. We cannot do that for longer than a few seconds, maybe on a parabolic flight or in a fall tower. And by bringing those materials to space, we can actually have them suspended in the middle of this furnace without touching anything for hours at a time, and we can actually extract all those physical properties that we need in the future to model new alloys on Earth. So basically, we just go to space to fill in some gaps, but very important gaps in knowledge for finding out new materials on Earth. And in the past, we had similar experiments, not quite as advanced as that one, but in the past we did generate new materials that were half as heavy for the same strength that you find now in aircraft turbines, new engines. And for me, it's really exciting to possibly work on the material that we will find in 10, 20 years down the road in new machines or new aircraft, and help us save fuel and save the environment. That is really exciting for me.
Yeah, it does sound like a good one, and just one of the many examples of the valuable science being done up there. All right, I want to turn it over now to the phone bridge, where I believe we have one reporter, Miriam Kramer with space.com.
Hi, yes, thanks. I am just curious, does the fact that you're going to space actually feel real yet? And if it does, when did it start to feel real for you? And if it doesn't, when do you think it will?
Just start it off?
Yes, maybe.
I don't want to say I'm a pessimist. I think I'm a realist. But when you get assigned to the mission, you just think it's so far off in the future, and there's something will stand in my way of getting this complete. And then you start to move closer and closer and closer, and it starts to get a little more real, but not very believable yet, I think. And then there was just one moment where it just hit me like a tidal wave, and I was riding on the crew bus in Baikonur to watch Rick Mastracchio and Koichi launch, and it was just beautiful sunrise, just barely pink sky, and these two guys are looking out at this rocket fully fueled, venting, smoking, ready to go as the crew is going up the ladder. And I was like, wow, 6 months, that's us getting off this bus and going on. And for me, that was, bam, it's real at that point on.
Either of you? Alex?
Yeah, I guess I kind of had a similar strategy, and probably everybody of us does it that way. The same happened in the astronaut selection, right? At the beginning, I had applied, and as a scientist, I knew the chances are so minimal. So I didn't believe a single second that I would become an astronaut. I kind of pushed this away because I didn't want to get excited. I didn't want to get disappointed by being knocked out of this selection campaign, which I knew there were so many really good people in there. No, only at the end, when it came down to like 10 people, and I kind of knew that I do have a chance. That's when I did not manage to push this away as it becoming real, and that's kind of a moment where you're kind of vulnerable, because then if you fail, or if you get knocked out, then you're really disappointed. And the same thing I kind of did for my space flight. I knew that there's so many things that are possible to get in the way. I mean, you might get hurt, there might be a medical thing, there might be a technical thing, some things that are completely out of your control. So I always had this psychological barrier saying, I might fly to space, but I'm not getting excited about it because maybe not. And even now I'm saying, hey, in 2 months, I don't know what's going to happen. But really going to Baikonur and seeing your friends climb in that rocket and launch to space, friends that you have spent the last 2 years training with, the last 2 weeks very intensive, you lived in the same hotel, you had shared every meal, you shared every lesson with them, and you saw them suit up, you actually helped them suit up in the morning, and you see them climb in that rocket and fly up there. I was excited for them, and I could not push it away. I was like, wow, this feels really real. And now being back in training for a while, I'm surrounded by the same training environment right now that I was for the last 2 years. It kind of sunk back down again, and I'm happy for that because I don't want to be, I can't be excited the whole day, every day. So it feels more normal again. Just there's single moments when it gets real again. When we train for a spacewalk, not a generic one that we trained in the last 2 years, but actually when we train for a spacewalk, for a hand grip, for changing out a part that I know Reid and I are planned to do on orbit, that's when it's really getting exciting again.
Yeah.
And I guess anybody would be lying if they said they would not be excited once they sit on the rocket fueled with 26 million horsepower underneath them, igniting. I think that'll be an exciting moment.
I would think that would do it.
That would be an exciting moment.
Okay, we want to switch now to the European Space Agency, which has some media they're hosting, and they also have some questions.
Hello, Nicole. This is Jules Gransai at the European Astronaut Center here.
Go with your question, Jules.
Hello, Nicole. This is Jules Gransai at the European Astronaut Center here. And we've collected some questions from our ESA social media followers for the crew. Can you hear me well?
Jules, I can hear you. How can you hear us?
Oh. Okay, so the first question comes from our Twitter follower, Edith Kotso, and she wonders actually if you will be able to do some volcanology on board the ISS, Alex.
You know, that's a very good question. I hope so. It kind of depends on how my old work objects work out. The ISS covers a big part of Earth from above. Basically, you fly over any point that's between plus 52 and negative 52 degrees from the equator at least once every few days. So if there's an active volcano, I'd be happily taking pictures of that. And actually, I'm indeed in contact with my old institute that I worked on as a volcanologist. They are very interested in getting views of volcanoes that usual Earth observation satellites do not give them, because a usual Earth observation satellite just looks straight down. That's the way that most images are wanted by the users. But for some things like determining the height of an eruption cloud of a volcanic eruption, it's really good if you have an oblique view from the side, or for other natural catastrophes, disasters. It's also really useful to get a view that only the space station can actually provide, which is a view into the sun glint, into the reflection of the sun. Usually you would think it's not a good view. Usually Earth observation satellites don't like that because you're kind of blinded by the sun. But some details of those pictures actually enhanced by that sun glint. And that's very valuable science and very valuable information that we get out there. For example, with floods, you can easily see which areas are flooded and which ones are not, which is hard to see when you look at it from above, actually. And so these are kind of gaps that I may be able to fill with photography. Also, Reid is really interested in that. With photography from the space station, I'd be glad to help out there.
Okay, and we're ready for the next question. All right, that might be our last from the European Space Agency. We'll return back here to Johnson Space Center and go ahead and Mark, I believe.
Thank you, Mark Rowe for Aviation Week, and my question's for Reid Wiseman. I believe, if I understand the timing correctly, after you've been there several weeks, the maintenance spacewalks might be able to resume. And I wonder what you're sort of anticipating that you may need to do first or second, and what you've trained for altogether in that regard.
So what are the objectives of these spacewalks, basically? You said one very key word in there, and that was maybe. And so we do have a lot of work left to do on these suits to make sure they're ready to go out for maintenance EVAs. We'll keep our fingers crossed. I know the ground team's working on it really hard. On the schedule right now, we have 2 planned EVAs. They could slip out at a moment's notice based on the readiness of the hardware. But the first spacewalk, I will most likely go out with Steve Swanson. He'll be EV1, and we're looking at the main task there is reconfiguring the P6 radiator that was put out with Sunita Williams and Aki from the Japanese Space Agency a few years ago. So we'll go and refill some of the ammonia fluid out there, and then we will stow that radiator, and that will be a solid 6 hours of work. We have a few other little get-ahead tasks that we may do, but that's our primary focus. And then a week later would be the second maintenance EVA, and that would be myself and Alex heading out. And the primary objective there is to clear the pump module, which Rick Mastracchio and Mike Hopkins put on this grapple fixture called the POA. And we need to clear out that POA so that we can do other contingency EVAs in the future. And so the main thing will be removing that pump module and getting it stowed in a more long-term position on ESB2. And then provided that goes well, that's actually going to take us about 3 hours. Alex will be riding the arm. I won't necessarily say it'll be easy, but it's a fairly straightforward portion of the EVA. But it's about 3 hours. And then after that, Alex and I will split up, and we'll be kind of running all over station doing some smaller tasks. I'll be rewiring part of the mobile transporter, and then we'll meet back up, and we have a good chance to do some get-aheads, maybe reconfigure some of our lights that aren't working so well and cameras that aren't working so well. And then maybe some cleanup on the MLM from Luca Parmitano and Chris Cassidy's EVA that got cut a little short. That's it in a nutshell.
Okay, and I believe we do have the European Space Agency back with us with 2 questions, so we'll return back to them.
Thank you very much. I've got another question actually from our Twitter follower, Caramel. It's for Alex, about what you're feeling the most apprehensive about.
Well, I guess not having been to space, I'm looking forward most to the perspective that we get there. That right at that moment, right now, I mean, there's only 3 individuals up on the space stations that can look down on Earth. Those are the only 3 humans outside of the planet right now. And that is a unique perspective that we can get from this laboratory flying up there. It's a perspective from the outside on our planet that shows us what this planet really is. And that is something that we cannot get otherwise, because usually if you have a problem, it always pays off to take a step back and look at it from a distance. And this is something that we can do from space station, and I think that is something that is transforming our mind, or at least it's something that hits us. That's what my colleagues said that flew into space before me, and that is important for me to see, and also important for me to capture in a way, to bring back to Earth and share with everybody down here, and maybe get a sense on how fragile this Earth is, and just build the awareness that we have to make sure we watch out for our planet and not destroy it through wars or climate pollution or anything. That is something that I'm looking forward to, and I think it's kind of my duty to do that.
Okay.
And our last question actually goes to Alex and also to Max. It's from David Jeremiah Lantz, and he wonders if and how you manage to sleep at night right now, given the excitement of the pre-launch phase, now the launch being 2 months ahead.
Окей. Я могу сказать, что на самом деле период предпускового возбуждения у меня еще не наступил. Пользуясь, ну так скажем, знаниями, которые были перед прошлым полетом, я так думаю, ощущение, что ты уже почти полетел, это, наверное, приходит на Байконуре где-то, может быть, дней за 5, за 7 до старта. То есть, когда действительно с утра до вечера ты уже сконцентрирован на своем полете, с утра до вечера ты уже продумываешь, как все это было, и то есть есть у тебя такое чувство, что ты почти уже улетел. Но, как говорят у нас в отряде космонавтов, что никогда нельзя быть уверенным на 100% до тех пор, пока ты не сядешь в лифт, который на ракете, в лифт, который поднимет тебя к люку. Но и тогда еще нельзя быть уверенным на 100%, потому что может быть всякие технические проблемы, может быть проблемы, которые не зависят от тебя и могут старт отложить. Поэтому я сплю на данный момент очень хорошо, и я пока еще не в той эйфории предполетной, которая будет.
I don't yet feel the pre-flight excitement, not yet. Based on my experience, I can say that yes, the feeling when that you're about to fly comes when you're already at Baikonur and when you're probably 5 or 7 days prior to launch there. And when you're busy with the upcoming flight day and night, thinking about what's going next, what is to come. And that's when you get this feeling you're about to fly. In addition, I know that we in the Cosmonaut Corps usually say that you can only be 100% certain that you are really going to space when you're already in the lift, which is taking you to the uppermost part of the rocket, and when you are getting to the hatch. But actually, even then, we cannot be 100% sure because certain technical problems can arise which are totally independent of what you are doing, and your launch can be delayed. So for now, I'm sleeping really quiet and I'm fully calm.
You seem really calm. We're with you. And Alex?
Yeah, I sleep very well right now, mostly because I know everything is on track. There are no major problems, nothing technical that could get in the way. So to me, I'm relaxed because we're on track. And also, I think as an astronaut in training, you have this psychological mechanism kicking in that you're not really thinking about space most of the time as you did before you became an astronaut. I noticed that with myself. When I used to see a picture of space station before I became an astronaut, I was immediately full of wonder, and I looked at Earth and how beautiful it is, and I was excited by the thought to fly there. Now I still have these, but when I'm in training, actually this kind of is covered over by this technical view. Now when I see a picture of the space station, I try to see, oh, this is this module, oh, and I see the handholds. Oh yeah, we did a change out of an experiment there on the outside during the training run for the spacewalk. So suddenly I have this technical view which covers over the romanticism sometimes and the excitement of actually flying to space. What gets me out of this, and this is why I really like those situations where I get out of this, is when I do like public relations when there's kids there. I mean, it's always amazing when we have a school class at the European Astronaut Center, and I lead them around and they ask those questions. I could see myself being there, like one of these curious little fellas asking questions. I was like, yeah, this brings me back. This brings the excitement back. And so I know this will come back at the latest in Baikonur when we really see that rocket, when we climb in there. I know this is back, and I know this is still in there. But in training, actually, that mechanism is not so bad because it kind of keeps you on a technical level without being too excited about all this all the time.
Right. That's interesting. Well, we don't have any kids here today, but we do have some students and interns here from the Johnson Space Center. So if we could fit in a couple of questions from them, if you'll just raise your hand. I think we have two on this side, and I'll start with the young lady. And if you could just state your name and...
Hi, Liz Bowman. I'm a Pathways intern from the University of Alabama. And this is for anybody, but what do you plan to do to inspire today's students to spark interest in space exploration?
It's a great question. I think as a parent of two little children right now, you start to realize as a parent that things that you set off to inspire kids with, that may not be what actually clicks with those children. And if you think back to your own childhood, I guarantee there were things that your parents almost did as kind of a side note or a footnote in your life, and that is what sparked you. Like for me, my parents took me to Annapolis one year to watch the Blue Angels fly, and I think they did it because they wanted to do it. But wow, it ignited me huge to go fly these jets for the U.S. Navy. And so I think just spaceflight in its own is so beautiful, so complicated, and so unique that we could try all day with specific tasks, but it's the things that we don't try that are probably going to really ignite the minds of some children. So if we can relay the message, great, but just going up there and working, I think, is a phenomenal motivator.
Okay, I think we have another one from the side. Go ahead.
Actually, if I can add to that,
I'm so sorry.
we do have quite a nice set of educational experiments. I mean, you call it experiment, but it's actually an educational activity that we do up there. We have little movie clips that we generate, and it's in line with what Reid was saying. It's not like to tell people what to do, what they should do in life, or why space science is so good. It's more like to just trigger their minds. And this is what Plutarch once said, right? I mean, the mind is not a vessel to be filled; it's a fire to be kindled. And that's what we're trying to do, like with little experiments that we do in space, just to show how different the space environment is to us on Earth. Like we do little things where we just like show small physical effects that we're used to on Earth, but they're completely different in space. And we send those videos out, for example, and just to give children a starting point to think of, oh, the world is not only what I see outside my door every day. It is much more than that. And I can actually grow up to be a scientist, or an engineer, or an astronaut, or a pilot, whatever I like to do if I embrace this and just learn about my environment, be good at school, study hard, and get this get this as a ticket for doing whatever they like to do later in life.
Thanks for adding that, Alex. Go ahead.
Hi, my name is Joshua Woods. I'm a junior at Columbia University, and my question is, basically, the ISS is a huge engineering project, probably one of the greatest that mankind's ever done, and it's accomplished that way through the collaboration of over a dozen different countries since International Space Station. And with that, you get advanced capabilities, more access to resources, all these different advantages, but also you have to overcome different language, cultural barriers, all these sort of things. And it's worked out pretty well so far. ISS is still going above the Earth. But in you guys' opinions and based on your experience, how do you think this will affect human spaceflight in the future when, say we have an ISS-2 and we have not a dozen different countries, but 2 or 3 times as many working on this one project when we're trying to fit together all these different philosophies and cultures? How do you guys see that working out in the future?
It can certainly bring some minor frustrations at times, and it can cause just a little more work. But I think sitting there watching a switch between English, Russian, and for Alex, any language on the planet that he would like to speak today.
It's called German.
And among 8 others. Anytime you bring in these outside cultures, viewpoints, and technical capabilities, knowledge, it offers so much more to this program. And I've learned so much just working with Russians and Germans. And so from that perspective, you can gain a whole lot. But taking a step back and looking at the bigger picture, if we really want to get off this planet beyond low Earth orbit, it's a financial problem, and it's not one that a single country is going to solve. It's one that our whole world is going to solve together. And so whether it causes a few little hiccups along the way, it's definitely the only solution that we're going to have. And me personally, it's a solution that I want because it brings together all of these people, and the result is fantastic. So I'm a big fan.
And it's something that shows us, just as you said, we as different countries, different nations, we have something together that is so precious because it gives us the science, the perspective, the first step out into space that nobody wants to give away. And that is a huge incentive to work together, like to work through day-to-day problems that you might have. It's just too precious, and half a space station doesn't fly. Like you really need to work together, and that's I think one of the major achievements of this wonderful laboratory. I mean, if you think about it, basically what you said, right? It's been put together by, I heard once, more than 100,000 individuals actually worked, and the parts that came together on orbit, they most of the time actually have never met down on Earth. So you really have to work well together to make that all fit together. And if you told me before we have this project, this is how it works out, I would say that'll never work. That'll never work together. But we have this space station up there, and it flies well. And we're sitting here as an international crew, and we work well together. And that shows it's feasible, and that I think it's a very good perspective for the future.
All right. Thank you, all three of you, so much, and thank you, everybody, for joining us. We are out of time. That hour went by really fast, and we want to remind everybody, again, that you can follow Reid and Alex on Twitter, and you can follow all the mission updates on our website at nasa.gov/station. Thank you.
Thanks, Nicole.
Thank you.
Thanks, everybody.